right, folks, hello and welcome back to another tutorial from Algovera. My name is Keaton. I am on the core team here at Algovera, and today we are going to be reviewing the first installment in the Algovera library, which is a MetaMask extension for Jupyterlab. On building out our library, we're aiming to empower data scientists to make it easier to build useful data science products on Web3. And again, the first installment of that is the introduction of the Algovera library. So we're going to go through how to install and use the Algovera library, as well as demonstrating some of the core functionality in this plugin for Jupyterlab. Again, this is geared towards data scientists who are familiar with Jupyterlab, so I won't be going over Jupyterlab basics in this tutorial, just how to use the extension here. So you can see we have our Algovera project here published on PyPy, and you can now install it as a Python package directly with pip install Algovera. So I'm going to go ahead and run that here in my terminal. And once we are downloaded here, there are some additional instructions for creating your Conda environment and downloading the wheel file. At this point, I have done those steps, so I'm going to go ahead and switch over to my Conda environment. And now that I'm in the right environment, I'm just going to go ahead and spin up the Jupyterlab instance. All right, here in Jupyterlab, you can see a few things. There's this custom MetaMask dropdown here, which gives access to two of the main functional components that we built in with this original MetaMask extension. If you go to our docs here in the Algovera handbook, there are also the actual commands you can run. Again, the connect wallet and send ocean commands are just mapped to the UI components here. So we'll go ahead and test both of those. But for now, we're going to get started and import the library into our front end here. Okay. From there, we can go ahead and use this or the command. I'm going to test this out, show y'all how this works through the UI first. So first, I'm just going to connect my wallet, which happened there. And then I'm going to go ahead and send some ocean. So one thing to note here is what's going on behind the scenes, and you'll notice this here in a moment. I'm actually sending test ocean to an address that we're creating here behind the scenes. So I just sent some ETH right there, and next, or some ocean, excuse me. So next I'm gonna go ahead and send a little more ocean and also ETH that I actually have in my wallet. So I'm gonna go ahead and click send. You'll see here I'm sending ocean and my 0.1 ETH. And so now I have created this test wallet behind the scenes here with the extension and sent it some funds. So now the way we actually use that wallet and use those funds is by this other command here in our documentation, which is buying and downloading a data set directly from Ocean Protocol. So Ocean Protocol is a decentralized data and algorithm marketplace, which we have been building on and has some very useful tools that allow data scientists to build on Web3. So for the purpose of this exercise, I'm looking at here a test data set on the Rinkeby network here on the Ocean Marketplace. And basically all you need to buy and download a data set from within Jupyterlab is the ID of the data set itself and the contract address of the data set pool. So I'm going to show you all how to get that. So from within the Ocean Marketplace, I'm on this dataset page here. You'll find the DID right down here, and you do want to access the entire DID, including the prefix. This method here takes the address as a string, so we're gonna go ahead and put that in as a string here. The next piece of information you need to call this buy and download method is the address, the contract address of the data token pool itself. If you're unfamiliar with what pools and data tokens are within the context of Ocean Marketplace, I definitely recommend taking a look at their docs. But for now, we're going to go ahead and just grab the address of the data token pool, which again is just available here on the data token breakdown page. Again, we're going to go ahead and put this into our method back in Jupyterlab. Again, it is a string. And from there, we're going to go ahead and run the method. Now here you'll see this is the test wallet address we've created, the ocean we have sent it, and the ETH as well. And again, this is available on all networks. As you can see right now, I'm on the Rinkeby test network. So what's happening right now behind the scenes is our MetaMask extension is actually going into the Ocean Marketplace, purchasing the specific data set that we indicated, and it's actually going to go ahead and download it locally that we'll be able to access here in a moment. So you can see this pop-up that says I have one Sarnar 14. That's actually the name of the token used to purchase this data set. So you can see first thing that we did is we had to actually obtain this token and then buy the data set itself and then download it locally. Again, here you can see in Jupyterlab, we're getting status updates, and finally the path to the actual downloaded data set locally. So here back in my other terminal, in my working directory, you can see I have a couple files here, including this data file directory as well. So from there, that is how we can then perform actions and work with the actual data set within Jupyterlab. So again, this is the first time that we're actually able to connect directly to a decentralized data marketplace on the back end, all from within Jupyterlab. So one other thing we are going to want to test here is a method for running compute to data jobs. So compute to data is a functionality within the Ocean Marketplace where you can actually train on private data sets and run algorithms based on data sets you can't actually see. And the way that that happens is we actually send the algorithm that you're purchasing to the data set itself, and then run the algorithm, and then the compute to data workflow returns either the trained algorithm or the output of your training. So again, if you go into our developer documentation here, there's another brief explanation and the command itself to run the compute to data job. So I'm just gonna go ahead and copy this into my new cell here. And for this, we have a few different data sets we're gonna work with here. And these are data sets that we have actually used for our generative art hacking session here. This is the data set we used. Just like the other method here, this will take a string, and you want to include the entire prefix here to the DID, and you also need the algorithm information as well, which we're going to go ahead and use this. Now, one thing to note is that these compute to data jobs can take a decent amount of gas, so you'll want to make sure the test wallet here that's spun up in the background is properly loaded up with gas. Okay. All right. So what I'm doing here is I'm just gonna go ahead and wait for a test transaction in the background to finish up, and then I'm gonna go ahead and run this compute to data job. So I'm gonna go ahead and run this here. We're gonna go ahead and wait for a moment as this processes, and we'll be back once the job goes all the way through. You can see here what we're doing first is buying the tokens to actually access the data set and the algorithm itself. So again, the way the Ocean Marketplace works is you have to buy, in many cases, individual access for the data token and for the algorithm token. So again, you'll see here, I successfully purchased the data set token, which allows us to consume the data itself. And then next, we actually have to buy access to the algorithm, which you can see happening here. And once the algorithm is purchased, you'll see the compute job is starting here. So again, this could take a while, and consistent outputs will be put here in Jupyterlab, configuring the volumes and actually running the compute job. But after this, you'll actually get the output of this compute job here, and this is all run from within MetaMask, the extension using inside of Jupyterlab instance itself. So hopefully this has been helpful. We think this is just a first in many steps to empower data scientists to build on Web3. Feel free to take a look at our documentation on pypi.org or drop by our Discord if you have any other questions.